Hi everyone, I hope you're well. This is attempt number 7 of me trying to record this lesson. My PowerPoint crashing every time. I hope you're keeping safe and well. I just found this gift very, very funny. I'm really missing doing some experiments. I don't know about you, but experiments are the best part of science for me. So yeah, I hope you're well and I hope we get to see you again at school where we can do some experiments. Today's lesson, you will need your chemistry book and your stationery equipment, including pen, pencil, rubber ruler, highlighter, calculator. Remember, if there are any keywords or key sentences that you need to write down, to highlight them and make them really stand out. This would be really useful for you for revision. When you look back on your notes, you'll know exactly where the keywords are just by using a highlighter, and it'll save you time as well if you do it as you go along. For this lesson, your time, spend 1 hour at the most, and if you have any questions, you please email your class teacher. As ever, remember you need to write the information in the blue boxes, including the titles, and you must take a picture of your work and submit it on class charts at the end of the lesson. Please remember you have to do this on the day that the lesson is set, and we will be checking. And here are some lovely examples of some notes that I have been receiving from you guys. So you can see on the left, for example, you've got some colours to make the headings stand out, and we've got different colour pens as well that have been used for questions and answers. So that one was really nice. I really liked that one. And then on the right as well, really simple idea, just 2 different colours. Headings are underlined, and really nice use of colours, as you can see there. So that one I really liked as well. So really well done for those ones. Keep them coming. And yeah, let's go on with the lesson. So here's your do now task. There are 6 questions on the slide and you've got 6 minutes. Try as many of these as you can. If you get stuck on one, you can skip it and move on to the next one. But I know you should be able to answer all of these questions. Use your notes as well. So if you need to use your notes from previous lessons, use those to help you attempt the questions. Please press pause and press play when you're ready. Okay, question number 1. List 3 things that show a reaction has taken place. There are a number of things that you could have written for this one. You could have written colour change. You could have written fizzing or bubbling. Either word is fine for that. And if you remember from last lesson, fizzing or bubbling suggests that a gas has been made. The next thing that you could have written is a temperature change. If you've got a log of wood burning in a fireplace, for example, you can actually feel the heat, and that's a result of a reaction taking place. Next thing that you could have written is light, like when we dropped a bit of potassium into water and a lilac flame was seen. And then finally, you can have a smell, which could be pleasant or it could be not so pleasant. It depends on the reaction. Right, question number 2. What is the product? Copper plus oxygen react. The product, I know you're all saying it, copper oxide. Question number 3. Name a group 1 metal. There are a number of different things that you could have written for this one, and this is where your periodic table would have come in handy as well. So the first thing that you could have written is lithium. The next example you might have written is sodium, potassium, rubidium, cesium, and finally the last one, francium. Francium, whichever one it is, that's the last one you could have written. Question number 4. If a metal gives away its electron really easily, is it really reactive or not so reactive? What did you write for this one? If a metal gives away its electron really easily, is it really reactive or not so reactive? The answer is that it is really reactive. If a metal gives away its electron really easily, that makes it really reactive. Question number 5. When an element reacts with oxygen, what do we call this? We call it an oxidation reaction. So remember, we're just adding oxygen, so it's an oxidation reaction. And then the opposite, when we remove oxygen, what do we call this? We call this a reduction reaction. Okay, well done for completing those questions. Remember, if you get a question wrong, I'm really happy that you're trying these questions, and from the work that I've seen, you guys are doing really, really well. So if there's anything on there that you find hard but you're still trying, I'm really, really happy for that. So well done for all of those questions, and let's go on to the next. So your lesson objectives for today, what we're going to do is acids. We're going to learn the name of common acids. We're going to state that all acids are H+ donors, and all acids and metals react to produce salt and hydrogen. And then we're going to predict the name of products when we see some reactions taking place. So for this slide, we've got the names of 3 strong acids. We've got hydrochloric acid, nitric acid, and sulfuric acid. And I just want you to take a minute and tell me what you notice about the acids that you see in front of you. So you can pause the video if you want, or you can just carry on listening to my amazing voice and tell me what you notice about these 3 acids: hydrochloric acid, nitric acid, and sulfuric acid. If you noticed it, well done. You do, of course, have H in all of the formulas of these acids. So hydrochloric acid has got H in it, nitric acid and sulfuric acid, all 3 of them have got H. So what do acids do? Why is that H important? If we put any acid in water, it will produce a H+ ion. In scientific terms, so a sciencey way of saying the exact same thing is all acids produce H+ ions in aqueous solutions. And we can use a diagram to explain what we mean by this. So here's a diagram for hydrochloric acid. You can see the H+ in red and this Cl- in green. So the formula for hydrochloric acid is HCl. The H is always a plus, which makes the Cl a minus. And if we put that hydrochloric acid in water, you can see that the H+ separates from the Cl-, so it goes its separate ways. So that's what it means when it says all acids produce H+ ions in aqueous solutions. Okay, H+ ions basically just go their separate ways. And you can say the same for all the other acids as well. So this nitric acid produces H+ ions in aqueous solution. There's the nitric acid. You can see the red H+, and you've got the NO3, which has got a minus on it because that's a formula for nitric acid, HNO3. If we then put that in water, you can see that the H+ separates. So this nitric acid produces H+ ions in aqueous solution. And similarly, if we've got sulfuric acid, here's the diagram for sulfuric acid, and you can see in sulfuric acid, if I put an arrow here to show you in the formula, there's a little 2 after the H, which means there are 2 H+ in sulfuric acid. So if we put this sulfuric acid in water, again the H+ ions will go their separate ways. So a scientifically correct way of saying this is that this sulfuric acid produces H+ ions in aqueous solution. So I'm going to give you 3 minutes, and what I'd like for you to do is just answer these really simple questions on acids that we've just done. So I want you to name 3 acids and then just write the sentence at the bottom filling in the blank. Please pause the video and press play when you're ready. Okay, what did you write for the first one? We've got 3 acids. The first one begins with H, hydrochloric acid. If you got that one, well done. Next acid begins with N. We've got nitric acid. And then the third one begins with S, and that one was, of course, sulfuric acid. And then the sentence at the bottom, all acids produce H plus ions in aqueous solutions. Right, so if you remember from the lesson that we did last time, we saw some reactions of metals with a number of different things. So we saw metals reacting with oxygen, metals reacting with water, and metals reacting with acids as well. So for this lesson, what we're going to focus on is just the reactions between metals and acids. So here's a picture that you can see that you will be familiar with from the last lesson. It's the exact same picture. What I would like for you to do is just spend 5 minutes, look at the picture of some metals reacting with acids, and answer the following 3 questions. Question number 1, which is the most reactive metal? Question number 2, which is the least reactive metal? And question number 3, we can see bubbles, fizzing. What does this suggest about one of the products? So take 5 minutes, or however many minutes you need. Press pause and press play when you're ready. So let's have a look. So look at the picture of some metals reacting with acids. The metals we've got are copper, sodium, lead, magnesium, and iron. And the first question asks us which is the most reactive metal. And in order to determine which is the most reactive metal, we're going to look for evidence of the most rigorous reaction. Out of all of these ones, we can see that the reaction between sodium and the acid has got a flame, making sodium the most reactive metal. Okay. To find what the least reactive metal is, we need to find the metal that doesn't look like it's doing much. So out of the other 4 that are left, you can see lead, magnesium, and iron are all producing some bubbles. Copper is sat there really kind of casually doing not a lot. So we can say that this is, out of the 5 of them, the least reactive. Copper is the least reactive. As an extension, we can kind of rank the others. We can say if sodium's the most reactive, magnesium is the most reactive after that. So it's the second because it's producing the most amount of bubbles. After that, it's iron. Then it is lead. And then finally, you've got copper. Just a little extension question for you. And then question number 3, we can see bubbles or fizzing. What does this suggest about one of the products? If you remember from our do now task, we said that bubbles and fizzing were a sign that a reaction had taken place, and it suggests that a gas has been made or produced, whichever word you want to use. Okay, well done. So metals and acid reactions. We've had a look at some metals reacting with acids. We saw a diagram of what it might look like when we have those reactions taking place. When metals react with acids, they always make a salt and hydrogen. And the general formula for that reaction is metal plus acid makes salt plus hydrogen. So I want you to take 2 minutes and copy down the information that you can see in front of you. Okay. So we know that when a metal and an acid react, they make a salt and hydrogen. And if we use the example of sodium and hydrochloric acid, if you remember, this is one of the 3 acids that we said at the beginning, sodium plus hydrochloric acid makes a salt and hydrogen. So I'm just going to fill in here that I know hydrogen has been made. I also know that a salt has been made, but I need to say the specific name of that salt. And I'm going to help you figure out what it is. So if you can see, we've got sodium plus hydrochloric acid. So the name of the salt starts with sodium And because it reacts with hydrochloric acid, the ending is going to be chloride because of this chloric bit. Okay, so it's your turn. So I'm going to give you 3 more reactions. 1, 2, 3. And I want you to use the one that we've just gone through together. Sodium plus hydrochloric acid makes sodium chloride plus hydrogen. Use that equation to try and determine the names of the products for your next 3. You've got 5 minutes. Pause the video and we'll go through the answers when you're ready. Okay, magnesium plus hydrochloric acid. I already know that the name of the gas that I'm going to make is hydrogen, so I can just fill that in. And the name of the salt, I've got magnesium plus hydrochloric acid. So the name of the salt is magnesium chloride. Well done if you got that one. Let's go on to the next one. Iron plus hydrochloric acid. Again, we know that the name of the gas that's made is hydrogen, and we can see that from the bubbles here. And the name of the salt that's going to be made is going to be iron chloride. And finally, in the reaction between lead and hydrochloric acid, we can see again we've got some bubbles that are produced. Those are hydrogen bubbles. And the name of the salt that's produced is going to be lead chloride. Well done if you got all of those ones correct. So we come to the end of the lesson. You guys have done really, really well. So for this last slide, you have got 4 questions and you've got 10 minutes to complete all of these questions. Please use your notes throughout that you've taken throughout this lesson to attempt these 4. If you really want to challenge yourself, you would try doing it without using your notes. But if you need to refer back, please do. So pause this video, and when you're ready to go through the answers, press play. Okay, are you ready? Question number 1. Name 2 different acids. There are 3 that you could have written. I just wanted 2 out of the 3. The first one, hydrochloric acid. I had to think about how to spell that one for a minute. The second one you could have done, nitric acid. And the last one you could have written is sulfuric acid. Question number 2. When a metal is placed in acid, we see some bubbles. What does this suggest about the state of one of the products? Is it a solid that's made, a liquid that's made, or a gas that's made? So anytime you see bubbles or fizzing, that's the other word you could have used, of course, it suggests a gas has been made. Question number 3. When a metal and acid react, what 2 products are made? When a metal and an acid react, we know that one of the products is a salt and the other product is hydrogen gas. Well done if you got that one right. Finally, we come to question number 4, where we have to complete the equations. So the first one, we've got magnesium plus hydrochloric acid. So we know that the gas that's made is hydrogen, and the name of the salt, because it's magnesium with hydrochloric acid, the name of the salt is magnesium chloride. The second question, we had one of the reactants that was missing, but we can figure out exactly what that reactant was. So we've got something plus hydrochloric acid makes sodium chloride plus something. So we know that hydrogen gas is always made when a metal reacts with an acid. So at the end, as our product, we should have written hydrogen. And to figure out what the name of the metal was, we have to look the name of the salt. And I can see that there's sodium in the salt. Sodium is the metal. And then finally, for the last one, we've got both reactants missing, even though we've got both of the products. So we've got something plus something makes iron chloride plus hydrogen. So the metal you can see is iron. And the name of the acid that must have been used is hydrochloric acid. Well done. That's the end of that slide and the end of the lesson. Don't forget, you must take a picture of your work and submit it on class charts by the end of the day today. Any questions, please email your class teacher. Have a lovely rest of the week, and I will see you next week. Bye.